A warm welcome to all of you. Many thanks for joining us today for this inaugural webinar of the Cool Up program titled Sustainable Cooling at the Urban and Building Levels, Cooling Buildings from the Outside In. It's great to see so many people joining us on the call today. Thank you all for making the time to be here with us. My name is Kristen Brand, and I am the Cool Up program communications lead and a managing consultant at Guidehouse. We're thrilled to be kicking off CoolUp's webinar series to focus on upscaling sustainable cooling in the Middle East and North Africa region, or MENA region. To set the scene for today's discussion, we want to dive into the topic. So a first and fundamental step in a holistic approach to accelerating sustainable cooling is the reduction of cooling demand. This also reduces the number and size of our air conditioners and cooling devices, and therefore the electricity used to power them. We can do this, for example, by employing measures both at the urban level and at the buildings level. So in today's webinar, experts from Guidehouse and the Global Cool Cities Alliance will discuss how cool services at the urban level and other sustainable cooling measures at the building level can accelerate sustainable cooling and enable cooling that's good for people and the planet. Let's meet today's speakers. So for today's discussion, I am joined by Nation Zermaili. Nation is a Cool Up program manager and associate director at Guidehouse. She focuses on aspects of sustainability in the built environment, both on the buildings and the building products levels, with a strong multidisciplinary background. She currently leads the implementation of the Cool Up program in our 4 partner countries, Egypt, Jordan, Lebanon, and Turkey. Our next speaker, Maria Cutter, is the Executive Director of the Global Cool Cities Alliance, which promotes policies and programs that build resilience to extreme heat around the world. Maria leads global programs that you may have heard of, including the C40 Cool Cities Network and the Million Cool Roofs Challenge. While based in the United States, Maria brings with her experience and examples that can be applied across the MENA region. And last but not least, we have Andreas Hermelink. He's the director at Guidehouse and part of the Cool Up team. He became interested in energy efficiency in buildings almost 30 years ago and has ever since dealt with the technical, economic, and social aspects, as well as the interrelationship of the individual buildings level and the building stocks of entire continents. Andreas has joined Guidehouse over 14 years ago, and in the Cool Up program works on the financing aspects of sustainable cooling. So without further ado, let's dive into the presentations, and I will hand it over to Nation to kick us off today.
Thank you, Kristen. Hi, everyone. It's my pleasure to present our program, Upscaling Sustainable Cooling today. The program is funded by International Climate Initiative of the German government, and it will run for 6 years. So we are hoping to get substantial acceleration of the measures that we want and increase the sustainable cooling in the region. Next slide, please. Oh, sorry, slide back. So globally, we face a range of energy challenges against the visible effects of climate change due to rapidly growing urbanization and heavily strained energy infrastructure in many regions in the world. This is particularly the case in MENA region. In the region, cooling constitutes a major source of energy consumption, and it is expected to grow further. Cool Up program promotes accelerated technological change in cooling demand reduction and early implementation of the Kigali Amendment and Paris Agreement in our partner countries. Next slide, please. So we are working on 4 action hubs, as we call them, Turkey, Egypt, Lebanon, and Jordan. The countries face similar challenges, but they also have completely different regulatory environment, financial environment, and a complete different air conditioning and buildings sector. Our aim is to provide technical assistance and support to see how sustainable cooling can be accelerated in all these countries and also extend the learnings to the MENA region. Next slide, please. And we are aware that this is quite a large undertaking. It's a huge challenge. And for this, we have built up the Cool Up Consortium with organizations that brings in specific expertise in their own core areas. On the right-hand side, you can see our international partners. Eco-Research brings in the technical expertise and policy expertise on F-gas regulation. IRCA Dresden brings in their state-of-the-art technical knowledge. UNDP is our partner to bring Cool Up program connected to the international developments as well as supporting the policy developments in the country. Frankfurt School of Finance is the expert that leads on the finance and business model development side. We have REGRI, our regional partner, to support us for the multiplication of the learnings to the region and also make sure that the actions we are taking are well established in the MENA region. We also have our local consultants, local partners in every country, IDGCO in Egypt, Istanbul Aydın University and UNDP Turkey, LCC in Lebanon, and NERC RSS in Jordan. Next slide, please. So if we have a quick overview of the Cool Up program, the program stems from the needs that covers political, financial, and technical side. Those are our three core thematic areas. We aim to support implementation of Paris Agreement and Kigali Amendment in the countries to enable a new or improved regulatory environment in the countries, to develop financial models and boost sustainable cooling. On the financing side, work with the international and national banks, and on technical side to enable natural refrigerants and energy efficient solutions to mitigate the rising cooling demand. We have a cross-segmental focus. We work on refrigeration and air conditioning in commercial buildings and air conditioning in residential buildings. This entails bringing together different worlds, energy efficiency and refrigerants, so-called climate change and protection of the ozone layer together. We are pursuing a holistic approach across the value chain. It covers the HFC phase down or the refrigeration phase down of synthetic refrigerations and replacement with natural refrigerants, replacement and safe disposal of the current equipment stock, improved cooling appliance operation. But clearly, sustainable cooling starts at the building envelope level and even before at the urban level. And one of our core aims is to start with the demand reduction measures. Therefore, I find today's discussion is very interesting and very crucial for our program, and happy to hear our colleagues for the rest of the presentation. Back to you, Kristen.
Thank you, Nation, for that overview of Cool Up. And now we will hand it over to Maria to give us an overview of urban level cooling and what the Global Cool Cities Alliance is up to. Maria.
Good afternoon. It's great to be here with you all today. Thanks for having me. So next slide, please. I work for the Global Cool Cities Alliance, and we were founded in 2011, and our mission is to promote programs and policies that build resilience to extreme heat through cooling practices. We are actively working in this space to accelerate the use of cool surfaces, which is cool roofs, walls, and pavements. We work in many areas around the world with cities, regional governments, developing countries, as well as other stakeholders in the private sector. You may be familiar with our work with the Million Cool Roof Challenge. We worked in developing countries and different areas all around the world. So what our aim is to grow the number of participants that are in the space of using cool surfaces, and help with connections of them to the implementers that use them. Another important area that we focus on is the research sphere. And we want to make sure that all of our implementers have understanding and awareness of current research that's going on in the technical and technology space. And we try then to link those two together to make sure the end users and the research base are familiar with each other to, again, try to grow the industry around accelerating resilience to extreme heat. So then, of course, we try also to network and make sure that everybody is on the know and that we are able to grow and expand our networks that way. Next slide. So we partnered with the C40, and the C40 is a group of the world's mega cities that are focused on sustainability in a broad array of aspects. So we worked with them and formed the Cool Cities Network, where it is focused on cool surfaces. And through that group was the main launching pad for the Million Cool Roofs Challenge. And then we are also promoting actively cooling through roofs and serve as subject matter experts. And then included that I'll speak about later briefly is our new initiative around accelerating the use of pavements for cooling. Okay, next slide. So this is an image of the urban heat island effect. As you'll see, the idea is that cities are much warmer than the surrounding urban areas. And this is mostly related to the morphology of the cities, in other words, the shape, and of course, the materials constructed of the built environment, which are typically dark, and they absorb and hold the heat from the sun's energy. Now, you should also note that it is not a simple dome around the city. It peaks and valleys according to, as you see at the bottom, what the surface is below it. So with trees and green spaces and fewer development, you definitely see a greater cooling effect. So the urban heat island is not just a daytime phenomenon, it is also an overnight phenomenon. Because what we want is we want the cities and the communities where we live to be able to cool overnight. And with the dense cities, as you see there on the dotted line, that the nighttime temperatures don't go down like we would like them to, which is when your body needs to recharge from the excess heat of the day. So cities are hotter on average than other areas of your communities, and they are accelerating in temperature at twice the national average and the global average as well. Next slide, please. So why should we care? I think a lot of times one may not be completely in touch with the reasons that we need to focus on extreme heat. Well, basically every system, every human system, every physical system is impacted through extreme heat. So there are certain specific metrics that we can connect to that, such as mortality. Mortality raises 5.4 per person out of 100,000 in deaths. Heat is the leading cause of death for any other natural disaster combined. So heat deaths on the annual are very much higher than other of the natural weather events. Violent crime and domestic abuse goes up. And we know this through looking at arrests and jails, actually intakes during extreme heat events. Obviously, hospital visits and even admissions go up during heat events too. And I'll note that it's not necessarily during the heat event, but it tends to be within a day or two after the peak. And that is because it takes a while for the extreme heat to impact those that have not been able to cool and recharge during the high overnight lows that are exhibited. Next slide, please. So this slide represents an actual case in Washington, D.C. in the U.S., where we see the increase in temperature or energy demand based on an increase in temperature. So it seems logical that a higher temperature requires an increased demand for energy use because it has a higher demand for cooling. So higher temperatures, higher demand for cooling, higher energy use. And this, of course, results in an increase in greenhouse gas emissions and can also lead to brownouts and blackouts when demand on systems go up by that extreme level. So what can be seen as surprising here is the fact that above a certain threshold of temperature rise, we see a dramatic shift in energy usage, the energy demand. So for example, in 6 degrees increase, we see a demand in cooling of up to 21% and accelerates rapidly beyond that. This is across the bottom in Fahrenheit, but you do see a couple notes there that transfer to Celsius. Okay, next slide, please. So this slide is really important because I think it highlights the need to layer on the cooling effects that is the purpose of today's webinar, how we see built environment and urban environment, and the effects of doing all of them in a combined way are not just additive, they're amplified. So that is really important in how we address cooling, because we want to consider all surfaces, including the building and the sustainable cooling strategies that Andreas is going to speak about today. Next slide. So this is the gist of cool surfaces. We typically think of cool surfaces as green, and they cool through evapotranspiration, or cool, which lighter in color or higher reflectivity. So it's important to note this image shows a comparison of a dark roof and a light roof. What we're seeing is that the colors aren't necessarily indicative of the cooling effect, because we can increase the reflectivity through the formulation of the materials. So particularly when we get to the pavement sections, I'll make note of this. But the greening, as you see on the roof, is you're able to cool the environment by having those plants that cool through evapotranspiration. And then other surfaces include permeable and porous. There's also blue roofs, and those are specifically designed for stormwater retention, and they hold that water. And again, the cooling effects that are experienced from the emissions, release of the water into the air, and that cooling effect. And then it drains over time. So double effect of cooling as well as stormwater prevention and retention. Next slide. So this is the detail then of how cool roofs work. If you compare the slides on the left and the right, or the images on the left and the right, you see the black roofs, and you can see how much heat is emitted back to the atmosphere. And even comparatively to the white roof, you see a significant portion that goes into the building as heat. So therefore, it is definitely seen that the cool roofs definitely reduce the heat load into the building. So that is a very important factor to remember. Then of course on the dark roof, then so much more air is reflected back, temperature is reflected back into the cities. Then the next thing that you want to remember is the reflectivity is the most impactful variable in determining the coolness. So the new white roofs then reflect 70 to 85% of the sunlight initially, and then 55 to 65% as it ages. So you do still see an increase in reflectivity relative to dark roofs, even though it is lower as it ages. And when we consider aging, it is a 3-year look at the weathering that is designated in cool roofs. So in that case, then we know that that is still 40 to 50% more than the dark roofs. Next slide. So when we switch over to pavements, and this is one of the reasons that in addition to our cooling in the roofs area, we are trying to emphasize the need to use pavements and dark surfaces on the ground as a key cooling strategy for fast change in urban warming. You know, the greening, the trees are well understood, green infrastructure, porous pavements are well understood, but there is a gap when it comes to pavements. So you can see the top, the floor image that shows the difference in temperatures of the grass versus the pavement. So red is obviously hotter in that image. So this emphasizes that there is a huge opportunity to achieve scaled cooling by being able to address the pavements. So to this end, we are engaging the manufacturing sector because we need to know what's available. We need to be able to show the business case to these manufacturers and show that it's worth their investment to innovate and provide more materials. And we're doing this not just in the US, but also in cities around the world. Then, of course, part of this, an important part that is aligned with the Global Cool Cities Alliance mission, is that we are able to support efforts to develop policies and programs that promote the use of cool pavements. Next slide, please. So here's an image. On the left, you see a highly solar reflective coating. And again, it is an example of the reflectivity that you see, that rather than holding the sun's energy, it is reflected into the surrounding area. And then, you know, the important thing to note here, this image shows a much lighter color, but since this was taken, a couple of the large manufacturers are working on advancing innovation around darker pavements, because there could be seen negatively that there are tire marks and different stains that can come on a lighter color. So the research now is trending towards the availability of a darker color that includes the same highly reflective formulation. So therefore you still get the same cooling effect. And that's important because, you know, when you think about even this color that you see, it is along the lines of concrete. So there's not a glare, and there are still the same safety requirements of standard traffic. And then to the right, the image shows the permeable or the porous pavement. This is similar to a program that is being done in Paris, where on extreme hot days, they actually water the streets that are permeable porous pavements in order to achieve the cooling effect. So that's a very neat project that's going on there. So again, you get the evapotranspiration, and think about the significant surface area that can be achieved with this kind of cooling in a relatively rapid fashion compared to tree planting, which often takes, you know, at least 15 to 20 years to achieve a substantial crown, to where a crown canopy, to where you would actually see a cooling effect. Next slide, please. Okay, thank you so much for your time today. I appreciate it. And please do get in touch if you have other questions, and you will see my contact information at the end of the presentation. Thank you.
Great. Thank you, Maria, for that overview of cool surfaces and what the GCCA is up to. And so before we move on to our next presenter, we'd like to collect your thoughts of the audience here with an anonymous survey question using the Mentimeter platform. So we will post the link in the chat window, so you can just follow this link that you'll find there, or follow the instructions that you can see on the top of the screen to go to www.menti.com and then use the code at the top of the screen. And so we'll give everybody a minute just to log on to Mentimeter. And our question today is, where are you dialing in from? Where do you live, and how important is it to apply such cool community strategies as presented by Maria? So this is an open text field, so please include your location and low, medium, or high as an indication of the importance of such cool community strategies. We'll give everyone a minute to provide some answers. All right, let's have a look. Great, we have some people joining from Germany, from Brazil even, welcome. The US, Turkey, and I see some cool up countries represented here from Lebanon and Turkey and Jordan, where the importance or need for this is considered high. Indeed, that's we consider that as well. So this is why we're bringing this webinar and this topic to you. See Egypt and Turkey, the Netherlands, India, very high. Great. Good. Keep your responses coming. Iran, high. Great, indeed. So let's keep this in mind, and then we will transition to our next presenter, Andreas, and he will tell us a little bit more about other sustainable cooling strategies. And you can go ahead and keep this window for Mentimeter open, as we have another question coming up later in the presentation. So over to you, Andreas.
Thank you very much, Kristen. So I'm really surprised about the amount of input we just got in the Mentimeter, and very great to see from where the audience is and how important this topic is that we touch upon today. So I will continue now with the building level cooling. And the first thing I would like to address is, so how does it actually relate to what Maria presented on the urban level cooling? So Please, the next slide. Maria has touched upon several strategies to achieve urban level cooling. So here we have a project where we created some concrete numbers on that. So what you see here is a district in Tunisia, in Tunis, its capital. And on the left, you see today's situation, which features a typical district. Also from an aerial view in the middle, you can see that we have a high density area with single family homes with 1 to 3 floors. Then above, we have a low density area, again with single family homes. But as I said, with a lower density, which is also important for the following results that I will present. And on the left, between these two yellow and red areas, you have a blue area, which is separated by kind of a main street in between. And this is a mixed area of residential and commercial, also including buildings with more than 3 floors. So what we did here is actually implementing some of the measures that Maria already presented using a very sophisticated simulation exercise to see the impact on urban design in an existing area. So very important that we talk here about an existing area. And of course, everything that we see here, you could scale up and even do better if you plan new districts, new construction. So the difference that we see on the right is mainly 3 measures that were also mentioned by Maria. So specifically in the main street between the commercial area and the single family house areas to the right, so in the east, we have lots of trees in the simulation. We have the yellow parts that you see on the right picture, which are shading elements, which were placed at locations where the local situation wouldn't really allow to plant trees. And the third measure, which was also highlighted by Maria, is applying white roofs, which you can also directly see when comparing the picture of today on the left and the vision for the future to the right. So let's see what the result is. Next picture, please. So here we see the results of temperature change, but first let's focus on the left side. What you see here is the situation on the 22nd of July at 4 p.m. Please note the orientation. So left is actually west and the top is north. That's important because you also see the wind direction in the windrows in the middle. And what we see in the left picture is the difference in air temperature between today's actual situation and the situation that we would have if we'd implement the measures that I just described. So planting trees, shading elements, and having white roofs. In the temperature scale, you can see that blue means it's getting cooler. And you can see that across the area, and it is a relatively small area, as you can see, it's just like 360 by 360 meters. Even in such a small area, these measures already create quite a significant impact all over a cooling down of the air temperature of like 1 Kelvin or 1 degree Celsius, if you like. So what you can also see is the impact of the wind, because it's blowing from the right, so to say, from southeast to northwest. And you can see when you interpret this picture on the left that the cooling measures that we implemented, they actually build up across the area, so that the further you go into the district, the more or the stronger the effect gets. So this means if we would implement these measures in a larger district, you would even see more prominent impacts. So this means more cooling down than what we see on this really small area here. So this is the actual air temperature. We can cool down for a little bit more than 1 degree Celsius. And the pattern, so how it builds up here on the left, is mainly influenced by the wind flow. So now let's switch to the right map. Here we see a different kind of temperature. This is the so-called physiological equivalent temperature. So in other words, the temperature that you and I would feel if we would stand on the street at a certain spot here. So it's really the perceived temperature. And what you can see here is, looking at the scale, that we can achieve much bigger differences than in air temperature. And what you can also easily see is directly spotting the local impact of the elements that we were discussing before, specifically the dark blue areas. These are shading elements and trees, under which obviously you will have a much lower perceived temperature, and the calculations, the simulations that were done here were done for 1.8 meters above ground. So to just give you an idea. So in contrast to the picture on the left, the picture on the right shows you that these patterns and the perceived temperature is mainly controlled by the shading elements. So now the question, of course, is how this links to the concrete energy consumption for cooling in buildings. Next slide, please. So what we did exactly for this 360 by 360 area that I just explained for the urban level is we picked 15 typical buildings across the whole district, and we tried to calculate, or we didn't try, but we did again with a dynamic thermal building simulation, how much useful cooling demand you would actually reduce by applying these few measures in the district I just showed you. So the savings, they amount to 3 to 5%. And at first sight, you may think, oh, that's not too much. I would have guessed this might be more, but as I just pointed out, first, this is a very small area. If we would apply, we would get more cooling of the surrounding of the buildings. So of course, then also get more savings here. And what we see in the picture here is not the electricity consumption of the air conditioning unit, but it's really the heat that you remove from the room, so from your building you live in or work in. And this is just the first step, of course, but then the next step of the chain is the efficiency of the actual cooling unit. And when you think about where these units are typically located, so yeah, on the street or typically on the roof, you can imagine that when going to the next level of calculating the electricity savings of this, we would see again significantly higher savings, because as we have implemented cool roofs here, the cooling units would be located within a much colder area, and the colder in summer the area is, where you have your outdoor units of the air conditioning, the more efficient they can operate. So that would be an effect that comes on top. We should also not forget that with these measures that we showed, the heat demand would increase actually a little bit because we have more shading. Again, on the demand side, but when combining it with the efficiency of the air conditioning, the net effect will be positive, obviously, for this kind of measure. Next slide, please. So this was the link between the urban and the buildings level. And of course, we can also think about more measures to achieve sustainable cooling, meaning getting down with cooling demand, with electricity use and greenhouse gas emissions, and also increasing the well-being of people working and living in the buildings. So the first thing, which I think shouldn't be forgotten, is what we call holistic planning. And this means that you should design very early for sustainable cooling. In new buildings, this means compact design, the orientation of the building, the sizes of the windows, and also by orientation, the sizes of the windows. That's something you can do specifically in new buildings, of course, and in existing buildings, also changing windows, For example, you can still decide, for example, about solar gain coefficient of the windows by orientation. That's also something you can do in the planning stage already, which moves us to the passive measures, meaning that you do not use actively energy to improve the comfort, but you really use passive measures, which partially also have zero to low upfront cost. And the impact of these passive measures is that they keep out heat and irradiation, and by this they support natural cooling, natural ventilation, for example. So concrete measures which are extremely effective is solar protection, specifically external solar protection. Then again, we have the white roofs, which not just on the urban level have a very significant impact on the outdoor well-being, but of course also on the indoor well-being and the energy efficiency and the energy consumption for cooling. Adequate insulation of roof, walls, and glazing, of course, also helps to keep out the heat. Very effective, and I will show also some examples that have implemented that very nicely, is night cooling. Of course, depending on how much your area allows to do that, how much it cools down overnight, which can differ significantly between different locations, of course. And what is also very helpful is a high thermal mass of the buildings, which also belongs to the passive measures, but also typically in this case more relating to new construction. So what we have here next is the active measures, which means sustainable air conditioning. First of all, you of course would like to use best-in-class efficiency equipment, but as has been already pointed out by my colleague Nishan, is also a focal point in our Cooler project that we use air conditioning systems with natural refrigerants. And in the next slide, you will see why this is so important for the overall greenhouse gas balance. What we can also do is automating passive measures. So just imagine you have an exterior dynamic solar shading. So you can, by use of some electricity or motors, of course, change their settings. You can move them up and down. And if you have lamellas, you can change the angle. So this is then kind of automatization of passive measures. That's another way to go ahead. And of course, we shouldn't forget about the operation. As we've already seen, Maria has shown how much temperature goes up with increasing outdoor temperature. Of course, we should not forget that energy efficiency or the cooling demand and the electricity demand of cooling, of course, also goes up the colder we have it. So therefore, it's very important to really be careful and cautious about or mindful, maybe that's the best word, about the cooling setting. So please avoid overcooling. That's the general direction. 1 degree Celsius already has quite a significant impact. What is also important, if you have all the technology in place, it shouldn't just work in T0, but of course it should also work over the full lifetime, which means that proper commissioning, user instructions, maintenance and monitoring is extremely important to really keep the high efficiency level that you planned for. Last but not least, of course, you should and could power your active devices with renewable energy. By either solar power or solar thermal. This is also possible depending on the technology you use, because the very nice impact we see here is that we have a coincidence between peak cooling demand and peak solar availability. So this goes really hand in hand, which allows you to maximize the use of renewable energy. Good, next slide, please. So the question now is, what is the impact of all these passive and active measures I just presented? Here, this is a qualitative slide that shows you the different steps that leads us from the status quo of today to a future situation that we would like to support with our Cooler project. The status quo, that's very important. It here shows you two aspects of the global warming. It's the so-called total equivalent warming impact. And this is put together of indirect CO2 emissions. So just take your electric-driven AC unit. It is the CO2 emissions that are generated by the electricity generation, so the power plants that generate the electricity. But you have also direct CO2 emissions from leakages of the AC units, which come from natural or not natural in this case, from refrigerants, from artificial refrigerants disappearing into the atmosphere, and they are causing very significant global warming. You can see in comparison to the indirect CO2 emissions, this can be extremely high, this share, up to 50-50. And the efficiency improvements that we can imagine now in the next step is applying an improved air conditioning unit with, of course, higher efficiency, using less electricity, which means using less or causing less indirect CO2 emissions. But you specifically see the much decreased amount of direct CO2 emissions because this unit would have a refrigerant with lower global warming potential and also less leakage. Then in the next step, we would apply the set of efficiency measures that I just pointed out, which again brings down, of course, the cooling demand of the building you apply these measures to, still having the same AC unit. The next step would be to apply renewable energy. This will completely eliminate, in the best case, the indirect CO2 emissions, and the only remainder then is the direct CO2 emissions. And this is the final step where applying natural refrigerants, so waiving of so-called F-gas refrigerants, will really get you to net zero, a net zero building, including the direct CO2 emissions from your refrigerants. So these technologies are mainly in place today. So what we see here on the picture is not science fiction, but it is what can be implemented on a large scale already today. And this is the driver for our Cool Up project. Next slide, please. So here I would like to finalize the presentation with providing you 3 examples, going from high-tech to low-tech, so to say. Here we have the high-tech example. It is the IRENA headquarters, the International Renewable Energy Agency in Abu Dhabi in the United Arab Emirates. The architect Woods Bagot, the concrete location is Masdar City. It was built in 2015, 7 floors, 32K square meters of floor area, so quite a big unit that we see here on the picture. And you can see the priority in this building has been on applying the passive design strategies to reduce the cooling demand, and compared to similar buildings in this area, the designers achieved a larger than 50% reduction compared to a business as usual comparable building. They achieved this by applying some of the measures out of the set I already presented to you, but here you can see the practical application. The building has a very well insulated building envelope. It has permanent shading elements. You can see that even the solar panels on top of the roof have been used as shading elements. On the facade, you see also zooming in maybe after this webinar, some of the fixed shading elements. In the middle glazed part between these 2 horizontal structured blocks, you see a vertically structured block which has vertical shading elements, so vertical oriented running from the top to down to the bottom. And what you can also see, although the building looks very shiny, the glazed area is actually relatively restricted, so it's not at all an all glazed building, which is also very helpful, of course. So the building also features a highly efficient enthalpy recovery ventilation system, which helps keeping the cold in and keeping the heat out. It's connected to a district cooling system, and I already mentioned the rooftop PV. Next slide, please. The next slide shows a picture which is a project that we have also supervised a few years ago. It is located in Jordan. It's called the Aqaba Residence Energy Efficiency, and architect Florentine Fischer. It was constructed in 2007, 3 floors, building 420 square meters. And what we see is, again, as series of passive measures: compact thermal mass, orientation of the building, thermal wall for heat accumulation, fixed shading elements, and it has a very innovative adsorption cooling system, even also applying energy efficient lighting and appliances. The primary energy consumption is less than 20%, so it's not 20% less, but it's less than 20% of a conventional new building in Jordan. And for the payback, we achieved for this pilot already like 12 years. And if you imagine scaling up what we did here, we assumed we could arrive at 4 years. So last but not least, let's call it the low-tech example on the next slide, which is an example from Egypt, a private beach house. You see this is built in 2018, architect and builder Calm built, the smallest of all the buildings we've seen, 245 square meters. Again, here focusing only on passive design measures, very massive construction, well insulation again. A highlight of this building is the free ventilation, the solar chimney that you see on the left bottom corner. PV is not directly on the building, but located close by. And yeah, as I said, the highlight of this building that, okay, located close to the sea, but it can live without any active cooling system and still providing a very high comfort to the dwellers. So that was an insight into some applications of what we presented. And yeah, I hand over to Kristen again.
Great, thank you, Andreas. A lot to unpack there, but I want to make sure that we have enough time to pose our last Mentimeter question and get some questions answered from the audience. So thanks again. And to the audience, go ahead and click on the link that you can find in the chat box or follow the instructions on the screen to navigate back to Mentimeter. So here we see that Andreas has presented a number of different measures to achieve climate-friendly cooling. And in your opinion, which of these measures strikes the best balance between broad feasibility and cost effectiveness? So this is a multiple choice question that you see on the screen, but I believe you should be able to select up to 3 options. So we'll give everyone a moment to fill in their responses. Indeed, so it looks like passive measures in the pink bar we see there, and designing early for sustainable cooling as well, as I think Andreas mentioned that on several occasions, indeed. So great, we also see highly efficient air conditioners or chillers as well. So great. I see some responses still coming in, but indeed it looks like those first 2 gaining the most traction here. Thank you everyone very much for your responses. And so in the last few minutes of the webinar, we'd like to switch to the question and answer session. So thank you again to Nation, Maria, and Andreas for your insights on the intersection of urban and building level measures for sustainable cooling. Let's spend the next, let's say, 7 to 8 minutes or so answering some questions from the audience. So also to the audience, please don't be shy and feel free to post your question in the Q&A window, and we'll do our best to answer it. So let's move to our first question. So going back to our first presentation from the day, this goes to Nation. So what can we expect from Cool Up this year, and how can the audience, or how can we benefit from the program?
Thanks, Kristen. Well, yeah, Cool Up program full implementation has started in 2021, and for the last year we have been conducting several baseline analysis about the regulatory landscape, our financing market, and the cooling and building sector in the partner countries. And additionally, we've been working on Cool Up's regional cooling status report. So in coming months, we will be sharing insights and findings of our first year work on our website through several presentations, in webinars, and in events. For example, my colleagues from Guidehouse and other partner organizations will be presenting in MENA, in MENA Climate Week at the end of March. We have a couple of interesting events and webinars where we will discuss cooling from different perspectives. And we will be present in MOP and COP. So I would suggest everyone to follow our website and register to our newsletter. Additionally, please contact us to share your experiences and your works and your challenges about sustainable cooling, so we can see cooperation potentials and what we can do to upscale sustainable cooling. In coming years, we'll be doing more on recommendations part for the regulatory analysis, and also actual implementation cases with demo projects. So we'll be sharing all these insights, which I believe will be interesting for everyone in the participants today. So looking forward to connect.
Great, thanks, Nation. Yeah, a lot to look forward to here in the coming year. And for the next question, let's actually hand it back to Maria. So, I see a question here. What other major global initiatives are you involved in through Global Cool Cities Alliance?
Yeah, thank you for that question. That's a great question. So we are very closely attached and working with the C40 Cool Cities Network and helping them advance these initiatives around the world. And as I mentioned, our work with the Million Cool Roofs Challenge focused on primarily on developing countries and how we can support their efforts to expand cooling. So we are working on those things for this year. It's just additional work addressing technical questions as well, because we get that a lot as new programs and policies come online. We're supporting those efforts. And, I think most importantly, we are going to attempt to launch a new initiative around the Million Cool Roofs Challenge and expand that even further, because we saw that as a very successful program. And of course, the key element that went with that is the fact that some money came with that prize, and folks were able to use those funds to fill the gap when funding was a big problem.
Great, yeah, indeed. I saw the winners were announced for the Million Cool Roofs Challenge recently. Yeah, good stuff. Now, maybe for the next question here, this goes to Andreas. So, how could we convince governors and designers to integrate cooling measures in early phases of urban development? So, these different stakeholders is what we're getting at here, integrating sustainable cooling into the early phases of urban development. You go ahead and turn your mic on.
Yes, good hint. Thanks, Kristen. So I think that's very relevant, and I mean, what we are doing here is already a first brick on this path, the first milestone. I think we need a lot more information on that. What we see in our practice is that many people, policymakers, and even some designers and planners, they are really not aware actually about how much can be saved by these early design measures. And I think a bit more examples and numbers in terms of the well-being of people, increasing productivity, which adds up to really big numbers in terms of cost effectiveness, also in terms of energy efficiency, of course. That would help a lot. Just to give an example, we recently did a study on what the impact would be on having a mass rollout of external shading across Europe. And it's really massive what you can see, how much air conditioning you could save from the predicted uptake that you see in the typical extrapolations towards 2050. So I think we just need to work on the awareness, and then people will understand how important this is to get it into the regulations.
Yeah, indeed. Thanks, Andreas. For the next question I see here, this goes to Nation. Is there any possibility for interested institutions or individuals to join the ongoing or future activities of GCCA and Cool Up? If so, how can they get involved?
Yes, thanks for the question. Indeed, so as I said, please do reach out to us via the contact information from our website. As I said, we're looking forward for the cooperation and also upscaling sustainable cooling with our learnings in MENA region to other regions in the world. So we'll be happy to see what are the possibilities to cooperate and have webinars or events together also with other people from other countries. Back to you, Kristen.
Great, thanks, Nation. And let's see. Maybe one more quick question to Maria and your experience with working with cities in, for example, India or Vietnam. Do you have any thoughts there?
Yeah, thank you. So what we've done in India was, I mean, I'll reference the Million Cool Roofs program again, but it was working with small communities where there were people in the most need, where we helped activate painting on roofs. And what happened there was that we were able to activate jobs in a local setting, as well as help promote manufacturing and the creation of new businesses that could support and produce those materials, cool materials locally. So roof paints and highly reflective things along those lines. And in terms of joining the Cool Roadways Partnership or the Global Cool Cities Alliance, simply contact me in the email listed there, and I will get you all set up. Membership is free and no obligation, no cost to participate for cities and nonprofits. When we get to the manufacturing side, we have small fees associated with that. So please just contact me and reach out, and we'll work with you from there.
Great, thanks, Maria. So lots of ways for our participants in today's webinar to get involved. But as we're approaching the top of the hour, I think we will leave it there for the Q&A session. I hope we answered most of the questions, but as mentioned, do get in touch. So we have indeed heard some excellent input today that's given us a lot of food for thought, and we'd like to keep up the momentum for sustainable cooling and keep bringing you relevant content. So do please take a moment to put in the chat window any ideas that you have for future Cool Up webinars. We would really appreciate that. As mentioned, you can find Cool Up and GCCA online. Cool Up recently launched our new website, as Nation mentioned earlier, with all kinds of information and resources, so be sure to check it out. You can also find us on Twitter and on YouTube, where we will post the recording of this webinar for those who couldn't make it today. So if you haven't already done so, please do sign up for both the Cool Up and GCCA newsletters to stay engaged and receive regular updates about our activities and events and sustainable cooling. So once again, a warm thank you to everyone for joining, for our speakers for providing their input. Thanks for your input and engagement in our webinar and in the work of both Cool Up and the Global Cool Cities Alliance. We hope to see you at the next event. Thank you.